I think everybody or most people know what Delve is, but I'll just say quickly, we're a full service strategy, design, and engineering firm. About 80 folks, 60 people in this office, 10 in San Francisco and 10 in Boston. And I'll let Brian talk a little bit about Midwest Proto before we jump in.
Sure. Yeah, no, we print stuff. We make goods. We're basically an additive manufacturing facility, service bureau. We print over 15,000 parts in any given month. We have over 8 different technologies that we can actually produce those parts in, as well as doing urethane casting. We have over 50 different machines. We have over 45 different materials. We have 3 facilities now, actually. We have our additive facility in Blue Mounds. We have a urethane casting facility in Mount Horeb. And we also have a satellite printing facility in Broomfield, Colorado. So, I guess the people always hear me say the most simplest way to think about us is we are the FedEx office of 3D industrial printing. You send us a file and we print it. We don't do any design. We don't do any engineering. We truly are focused on materials and production and do it at a very high level.
So a few things we're going to touch on tonight. We're going to really see what's the inspiration for additive manufacturing. Can additive manufacturing bridge that gap? Really understanding where design and collaboration between the engineers and designers and your additive manufacturers come in. And then thinking about how additive manufacturing really can help your organization beyond just prototyping or changing the way you make stuff. So, when we're thinking about additive manufacturing, there's one thing I'm just fascinated. I can still sit in front of a 3D printer and watch the thing build, see it grow out of that resin or out of that filament. And try to figure out why is that so fascinating. It does feel a little bit futuristic, but I would say it kind of feels like a complete throwback to the beginning of nature, where an assembly line, and I apologize, Dave, who worked at the GM plant and worked on manufacturing and assembly. An assembly line is kind of dehumanizing. You're doing these processes that are really just around that process, where 3D printing feels more like a leaf in time lapse, coming out of a tree. It's very, very natural. And I'm really kind of building on something that one of the people that I follow, that one of my heroes, Neri Oxman at the MIT Media Lab, and I'll just read this quote to you. Assembly lines have dictated a world where designers have been taught to think of their products in terms of assemblies of parts, each made from a different material and fulfilling a predetermined function. We're now moving from a world of parts to architectures that combine structure and skin. So if you could think of printing the whole thing where everything is in one part, that's the world that she's making. And she's really pushing the envelope where she's trying to make that connection between nature and what we can do with additive manufacturing. This is an installation at the MIT Media Lab where they wove some fibers, some man-made fibers, into the structure, and then they went and bought a bunch of silkworms and dumped them on the structure. And the silkworms are finishing the structure with their silk. So it's a combination of man and insect, or whatever a silkworm is.
So 3D printing. I mean, here we are talking about two very different things, right? You have nature and how nature creates things, and then you have manufacturing and the manufacturing process. And it is this gap that we're looking at, and it's looking at the ways that 3D printing can help fulfill and kind of fill that space in between. But that being said, 3D printing is in an interesting spot because it's truly we're in an industry that we're building the plane while we're flying it, and so it always has been coming up short when it's come from a machining standpoint. Trying to keep up with CNC, trying to keep up with sort of traditional manufacturing practices, and then at the same time, it's really not nature either. Even though we can get more organic shapes and we can get more complex shapes, there's always this sort of intermediate step. And we see a lot of that moving forward. We see a lot of technologies, and I want to make sure, to sort of preface all that we're going to be talking about tonight, and the fact that, there are a lot of things we hear about in 3D printing. There's a lot of things we hear about in additive manufacturing that are truly futuristic. And those things we can lay out on the Gartner hype cycle. And so you can see where what I work in and where my world exists versus where things lie on the Gartner hype cycle. And if you've never seen a Gartner hype cycle, go online and look at Gartner hype cycles. They have Gartner hype cycles for everything, telecommunications, for all sorts of different technologies. But with the Gartner hype cycle, it's the major components is an innovation trigger that then creates a peak of inflated expectations, moves to a trough of disillusionment when we realize that actually the technology doesn't do all the things we thought it would do. And then it becomes the slope of enlightenment where we actually realize, well, it actually does do something, but it just doesn't do all the things we thought it would do. And then we end up in the plateau of productivity. And so when you lay in additive manufacturing, you start laying all these technologies out. You start looking at the things where if it's in yellow triangles, these are things that are just triggering right now. If it's in the dark blue, it's 10 years out. If it's in light blue, it's 3 to 5 years out. And if it's white, that's happening now and today. Oh, I just turned it off. I'm unfortunately put the buttons right next to each other. And so you look at all these technologies and these are the things that people love to talk about. Like, hey, are you guys printing organs? Are you guys doing 4D printing? Looking at 3D printed drugs and things like that. And it's like these are all super cool. Don't get me wrong, but I'm up here in the really boring plateau of productivity, which is these are the things that you can actually commercially make money on. And those are the things you can build a business off of. And so I just want to make sure to sort of set the preface that when I'm talking about what we're doing, and before people start asking me questions about some of the other things that are over here in the peak of inflated expectations or down in the trough of disillusionment, that really we're up here on this boring plateau. But what I really like about it is that we're the ones that are pulling everything up onto that plateau because we're making these things happen and we're creating a commercially viable business through working in that plateau. That makes sense. So basically 3D printing has really been used for prototyping. I always, our company actually, as innovative as we are, we've been around for 19 years. We're still using machines and we're still using materials. Accurate 25 is one of our stereolithography materials that we've been using since 2002. And we have 5 machines that run on Windows 7. We don't know what we're going to do now that they can't service them anymore because we can't upgrade the machines. But those technologies still work and they still work great. But it's been for prototyping. It's been for, this bridge of this idea of hey, how can I get a model figured out before I have to go to plastic injection molding? Or how can I get a part that looks sort of like a part that would be plastic injection molding? Hey, if I squint, it really does actually look like a real part.
Yeah, what is your name?
What's that?
What's the name of your company?
Midwest Prototyping. So, which we sell globally, and we do more low volume manufacturing now, more volume production than we do prototyping. So, but it's hard to change names.
Is it hard to change names? No.
One of yours did it say? So the other is that 3D printing, additive manufacturing is when customization is critical. Obviously printing things for the human body, printing things for individuals. Printing things that are into mass customization is when 3D printing becomes really a crucial component. When doing manufacturing assembly fixturing, so producing 1s and 2s for a very specific assembly or a manufacturing line that hey, we just need this to be held down by this, and it becomes a very custom part. And the other is creating impossible geometries. So there are truly things that we are creating that they could not be produced through any other technology. And we have customers. This is a great one where, they had us design and make this part for them that they could put GoPros, basically do a 360-degree lens that they could then run up on a big pole. And the idea was we were going to create the prototype for them. And then they took it to manufacturers to try and figure out how it was going to be manufactured. And they came back and said, we can't find anybody to manufacture this. And actually, it's cheaper to just print it. And so we just printed them until that technology didn't make any sense anymore. So, which is also interesting as well, because, if they would have plastic injection molded that thing, they probably would have printed 50,000 of them, and there'd still be a warehouse of 35,000 of them somewhere. So, again, impossible geometries, things that in spaces that you wouldn't be able to fit otherwise. And that's really what's fun about this industry is looking at the possibilities that were formerly impossible. So, and we're really approaching this tipping point. And that's what's really exciting right now, is that plateau of productivity, the finishing level of components, and the level of detail that we're able to provide, the accuracy and the tolerances that we're able to now achieve, getting into things like elastomerics, getting into airtight, watertight, things that can operate, parts that can operate as any other part would, from a manufacturing and a final use basis. And so that's where we're at, and we're moving forward, is this whole idea that we're approaching these methods, but we can't just say that, hey, we're going to replace plastic injection molding, we're just going to replace. We need to start thinking about how we're moving beyond that to the next level.
So that's the next challenge, is really changing that mindset. So we talked about, Brian talked about being the FedEx of 3D. I think that's awesome. That's like the bread and butter. But if you're really pushing beyond, just getting a prototype that you can look at and maybe it lasts for a day and you throw it out, you do your design change, and you move on to the next design iteration. If this is going to be a manufacturing method, if it's going to replace injection molding, you have to think about designing in a different way. So, for example, if you're designing an injection molded part, for all the engineers in the room here, you're not just going to say, okay, I finished it. When are my parts going to be here? That just doesn't happen. You have to engage with the manufacturer. You have to do design for manufacturing. You have to figure out where your gate locations are. You have to figure out how you're going to do, if you're going to do multi-cavity to drive the prices down. They're going to do mold flow, and they're going to ask you to change features to make the part feel better. That's just an expectation of working with injection molding. Sheet metal is another great example. If you're going to take advantage of a process, you have to say, how can I get the most parts on a sheet of material when I'm laser cutting it? What are the stamping dies? What are the punches that are already standard, so I don't have to buy custom punches, and I can replace the shape of a hole with something that's close to what they have. Just something that you expect if you're going to design a sheet metal part. So why shouldn't you collaborate with a 3D printing expert, an additive manufacturing expert, to figure out how to take advantage of that process and get the most out of it? Reorient a part, redesign a part to get more inside of platen, sort of the build area that you can do. Combine materials, figure out if there's anything that's going to require support. Can you change the design? Can you combine features? Can you provide the whole assembly to your to the service bureau, so they can say, hey, I see this, now I understand the context. What if you did this? What if you combine these two parts? We could save you some money. So I think that's one of the takeaways from today is, how can you design different with additive manufacturing?
Yeah, so this is a great example of a project that we did with a company called Delve, and great industrial design firm. They changed their name. It worked out well. Sorry, I'm just going to keep giving you hassles about that because you gave me hassle about it. This was one where the designer came to me and said, hey, okay, I want this printed in SLS, and then we're going to overmold these parts, and can you give me a quote for this? And hey, if you guys run it through your Post Pro 3D, it'll be watertight, right? So let's do that as well. And I was just like, let's back up. What are you trying to do? Because I don't think the technology's right, then I don't think the material's right, and let's talk about what you're trying to do. And it was, well, we're pushing saline through these lines, and then we have an actuator that's actually pinching off these softer areas to stop the flow of the saline, and so that's why I need it to be hard and watertight in some areas, and then rigid and pliable. And I said, well, actually, if we use the carbon technology, the rigid polyurethane, which this is an RPU, and then the elastomeric polyurethane, they actually have the similar molecular structure to become isotropic when we cure them. And so they actually bond together. And so we could actually take those parts and print them separately, put them together, and they would bond to the point where, we threw this thing and knocked off the ends and pumped it up to over 100 PSI and couldn't break it. And then you can also see me, I guess it's a sort of a slow thing, but I was like, you know what, I'm just going to break the thing. And so I grabbed it and started yanking on it, and I couldn't break it. And so we had to find somebody bigger and stronger than me, and Tyler in SLS finally broke it for us. But it was just this idea that it's like, here was something that if it would have been like the FedEx office model where it's like, hey, just give me a quote for making this. It wouldn't have been a project that would have gone forward. But to be able to work early on with the designer and talk about what they were trying to achieve, we were able to get something that not only was more functional, but actually was cheaper than any other production method that they could have done. And then it even went further because some of the initial designs, the way that even these parts were designed, they needed support structures. And so we talked about, hey, if you could put some holes to basically make these volumes not trapped, we don't need any support structures, and we put it right on the printing platform. And so then all of a sudden it was like, wow, we could print 250 of these in one print and pop them right off, put them right on the pieces, and move them through. So anyway, a little hard to talk through them. Well,
yeah, sorry.
Tyler's so.
Yeah, you want to talk? I talked a little bit. I'll touch on this one. So this was another Dell project where in the past we would just send the files, ask for them back, go send someone out to Blue Mountains to pick them up, put them on our circuit boards. This is low volume manufacturing. We were trying to make about 100 of something. So we said, well, we're not going to invest in the tool. Let's just do this. The first batch came back, and this little button was tight, and the engineer was kind of frustrated, and went down to the shop, got out a reamer and reamed that hole a little bit bigger, and said, "Oh, I really don't want to do this 100 times." And we said, "Okay, well, why don't you call Midwest and just explain it?" And really, the focus was, okay, there's only 3 critical dimensions here. It's a couple of clearances and a couple of interactions between the parts. And you can sort of talk about, how you dealt with those areas.
Yeah, well, it's one of those things that, as I said, we print 15,000 parts on any given month, and so from that standpoint, our technicians are seeing a lot of different parts, and they're seeing a lot of different materials and a lot of different geometries. And so from that standpoint, it's like, hey, let us know what the critical dimensions are, because we can orient the part in the build. We can also choose the technology based on the tightness that you need of a tolerance, or what is the most critical dimensions. And so by having that conversation with the designer, we were able to change our build orientation so that when those came out, they were all correct. And at the same time, we're able to create our own check guides. And so, hey, let us check it before we send it off to you. Rather than us, we just print it and hand it over to you. Like, we want to be a part of that process and make sure you're getting exactly what you want and exactly what you need.
Then I just love this case study. This is another project. It's essentially a medical device that you see here on the right in all the light blue and dark blue that we instrumented to turn into a training device for surgeons to do this procedure. So everything to the left, that the left hand is touching right now, is a 3D printed assembly with a bunch of sensors in it. And it, was a perfect application. On the other hand, it was, as we're doing low volume manufacturing of this in our own right and figuring out all of the critical dimensions, and the aesthetics, there are a lot of hiccups of getting these parts made to the quality. And so the back and forth and really the integration of the manufacturer and the engineering team was critical to getting this made.
Yeah. And I would say it's funny is that you talk about all these technologies and things like this, that it comes back to relationships though too, where, having the situation where something goes wrong and instead of like, oh, this is going to be wrong, it's like, hey, call me. Like, let's talk through what you're trying to do. And creating that trust between the different groups so that we can, have problems. We can talk about the difficulties of things and we can actually then solve the problems together. And that's a lot of what we did was me talking to my project managers and just saying, hey, if you picked up the phone and called, like, why don't you just call them? Like, stop sending emails, like, get in the car, go see them. And those are the things that really matter when trying to get these technologies to work with successful design outcomes. So this is a project that we have with, we work with some fairly large OEM machine producers. This is actually at a machine that is larger than this room. This was a particular instance where they came to us and were saying, we're trying to get this thing running. It's a huge drum that has 6 of these pistons around the outside of it. And they were trying to figure out, we can't get the brakes to work because when we engineered it, we didn't think about the centrifugal force that was being put on this thing. And so when it's trying to piston out and we're trying to get it to brake, it doesn't slow down fast enough. And so it's breaking the paper webbing that's going through here at extremely high speed. And so we need to figure out a way to get a stronger brake. And we said, well, you know what if we actually worked with you and we lightweighted some of the part itself so that you weren't having to break so much mass? You could actually, maybe the current brake would work. And so working with them, we actually redesigned this part to lightweight a lot of these with laser sintered nylon 12 instead of metal. We took 9 pounds off of the piston and all of a sudden it worked great. So there was no issues. They're like, it's not a brake issue, it's a weight issue. And it was fun to have that collaboration. And they in fact came back and said, could you go through the entire line and look at all of the areas where you could replace what we're doing in metal with nylon 12 and 3D printing? And that was where we were able to take stuff like, 15 parts and turn it into one printed part, 7 different, turns and turning it into one part, which is really cool. So the other is that I used to work as a Finnish carpenter out of college. I did Finnish carpentry for Urban Outfitter and Anthropology stores all along the West Coast. You don't know how people suffer for retail. And the thing was, as a Finnish carpenter, you kind of come in and everybody's behind schedule, except for the merchandisers. They're coming in on the date they said they're coming in. They're bringing all their stuff in. And so all of a sudden the Finnish carpenters are like, hey, you've got 3 days. And so we would just come in and basically work around the clock and get these done. And it was like, well, if the wall doesn't meet this wall, it's like you make it work. If these things don't connect, you try to figure out how to make it work. And that's really where additive comes into play with a lot of these things. And we work with different groups where there's different teams that are producing different parts, and they put it into a biomedical device or they put it into a machine, and they're like, okay, we need this to connect to this and this to connect to that. It's like, just draw the lines, guys. Like, we'll print it. We don't have to have it machined, and it doesn't have to be exactly correct. And frankly, if it changes and you come up with a different design for one of those pieces, we can just very easily change the part and reprint it in a different way.
So I know we're preaching to the choir for a bunch of you. Maybe a few of you will be inspired to think about moving from prototyping to manufacturing with additive. But even if you do that, you'll be at the beginning of the adoption curve. But if you just focus on that one area of just adding a new manufacturing method to your company's process, you may not be taking advantage of everything you could. So I'm going to introduce one framework that's a bunch of you have probably seen before. It's Doblin's 10 types of innovation. And it's basically saying if you can combine a few different types of innovation across your process, that's where you get sustainable market advantage. So that involves things across these 3 areas of configuration, offering, and experience. And we're just going to talk about building off of product performance, which would be basically like that lightweighting example that Brian had, to a few more areas. And first, that is that product performance. It's like you do want to focus there first. How can you take advantage of the process to improve your product performance. But I think we all know that that really keeps you track here. You know, that keeps you ahead of specialized for about 2 months if you hit product performance, and then the competitors are going to catch up to you. So potentially you can think of, I'm going to just offer a few here. You can think of profit model. How can you monetize this new process? Potentially, you could be taking advantage of using spare parts. You can think of different ways to price your product because you are now manufacturing it differently. You don't have inventory. Maybe you're saving money there. So pass it on to Brian to sort of talk about that profit model idea.
Yeah, well, you know, it's always we always get people that are like, you know, oh, but 3D printing is so expensive. Like the parts so expensive. Like we can get plastic injection molded parts for so much cheaper, and it is true when you've got a mature part and when you have, you know, something that's not very complex, and frankly, when you know that it's exactly what you're going to want to do. But when you start looking at quantities versus cost per part, you know, we're the flat line in the middle, which is you know, it may go down a little bit, but for the most part, it's like we're the same cost no matter what. But when you're talking about quantities and in low quantities, it's very important to do the calculation when you're starting out of, you know, where does that line actually intersect? Where does it make sense to actually move over to plastic injection or move over to another, you know, sort of traditional manufacturing process? Because there's a lot of creativity between here and here. There's a lot of flexibility between here and here. And if you know where that space is, play in that space as long as you possibly can, because that's where you're going to get the most innovation. So as well, when you start looking at the cost per part and complexity, you know, as it gets more complex, it gets more expensive for plastic injection molding or for other traditional manufacturing, for CNC, stuff like that. The beauty that I always tell people about additive manufacturing, complexity is free, 100% free. Doesn't cost any more to print a more complex part than it does to print a simple part. And so take advantage of it. So, you know, why print a part in 3D that could be plastic injection molded? And that's what we get a lot of times. We'll have people that will send us like, could you quote us 30,000 of this part? You know, and it's like, well, here's, you know, it's $2. Oh, we're hoping it'd be 20 cents. And it's like, well, the material's 21 cents. So no, we can't make it up in volume. And we don't want to make it up in volume. Can you send me the entire assembly so I can look at the assembly? Because you know what, I might be able to take 5 of those parts and turn it into 1. So, and that's where you have to sort of look at the overall embodied costs that happen within the manufacturing process. You know, when you're looking at an assembly versus looking at a part, in additive manufacturing, the part cost is everything. There is no assembly. There is no other components that have to happen. There's no tooling that has to come there, that has to be, you know, reproduced. I mean, if you think tooling is expensive, try retooling. Like, not only is it expensive, it's demoralizing for a design process to have to go back and retool stuff. New parts that have to get built, you know, all of a sudden it's like, well, now we got to redo and get all these out and replace all the old parts. They have to be warehoused. So the idea that, like, you know, I said earlier, where there could be a warehouse somewhere with, you know, 300,000, you know, parts that are never going to be needed again because they were off by 3 millimeters. And that's, you know, the beauty that we have is like we store electrons. Like our digital inventory is what we hold. We don't hold physical inventory. And so digital inventory is a smart way to think about moving forward in the manufacturing process.
And Brian introduced me to a term called gray space, which is just kind of that wasted time to dealing with tooling, dealing with the lead times, dealing with having to retool, when if you can stay in that flexible space for as long as possible, where you can iterate, where you can move to the market, it's very hard to quantify that cost, but it is a real drain on your company.
Yeah, and so just a quick case study on this. This was something that we worked with a customer on. You know, they said, you know, hey, we can get these plastic injection molded parts for $0.25 a piece, and it's like, all right, well, let's look at it. You can get your parts for $0.25 a piece. Your screws are 55 cents. Your O-rings are 75 cents. Labor's $4.15. Take, you know, $5.70 to assemble it and $9,000 in tooling. So, or we could print it, the entire thing, for $9. So, you know, you start laying this thing out where you take your material and labor cost, you take your mold cost, you take the number of units, And you start going down, and it's like, well, hey, as a matter of fact, we can tell you that until you're doing 2,700 units, you're better off having us print this as one part. And this doesn't even account for the fact of like how many different suppliers is that? Like, how many different people do you have to order parts from? The cost of inventorying those parts. What happens if all of a sudden they don't make that screw anymore? What happens if, pray tell, there's a virus that all of a sudden that shuts down a country and they can't ship stuff anymore? Like, what would you do? And so that's where it's like you can't even look at what those calculations would be.
Right. So this is obvious been talking about it. Really, how can you change your manufacturing design process? How can you streamline your company? How can you change your operations so that you are a leaner operation? You're focusing on innovation more. You're basically leaving more time and more money for customer service and less for dealing with the process of making parts and making assemblies.
So this is a bit of what Jesse was talking about in gray space, just the idea that in the traditional manufacturing process, you have to remember that every time you're moving from one of these to another, there's a delay and there's time and there's potential hiccups, there's potential pitfalls. Additive manufacturing, we're cutting this down to 4 steps. And the idea that I like to say is that I think that, listen, there's certain days that I'm like, I feel like we're printing a freaking landfill. It's like we're just making parts. And but the reality is I truly think that we are creating efficiencies because we're helping that innovation process move faster, and people are getting the bad ideas gone and the good ideas forward. And so we're not producing as much waste because we're just getting better design. And at the same time, it's like this idea that innovation, the faster it can come from the brain and into the hand, like the faster that we can get to good parts, the faster we can get to good design. And that's really where I think additive manufacturing plays, is getting rid of that gray space in the traditional manufacturing process and bringing forward innovation.
And so the last area of innovation, that 4th piece potentially that can really create a moat between you and your competition, could be in service. How you deal, and I'm really talking about customer service here, how you deal with your customers. Can you offer spare parts that are closer to them? Can you inventory and do just-in-time delivery to them? Can you offer kitting? Can you do other innovative things? And Brian will talk about a couple of interesting examples.
Well, here's a couple, just sort of fun mind blowers. One is, because we're printing in laser sintering, we're printing in nylon powder. We can just put a box around the parts and we can print the box. And so we can actually clean the parts inside the box, and we can give you the parts that are all contained within a box. And we can even put a QR code on it so you can inventory all of those parts as an assembly rather than as individual parts. So if you have, like, the one that is the best example for us is like masking. So if you're setting a bunch of different things to mask the painting of like an automobile door, it's like all of a sudden we've got 35 parts that are in there that are the exact parts that you need. There's no more, no less. You don't have somebody that's sitting there picking them out and putting them into a tray and passing them out, and all of a sudden they forget. So it really creates this great ability to kit these things. The other is, when I talk about printing assemblies, is actually printing moving assemblies. This is actually over on the table over there if you want to. It's a fun toy. But this was printed as one piece. It wasn't printed as individual pieces and assembled together. It was printed as one piece, cleaned as one piece, smoothed as one piece, and dyed as one piece. And the idea that we can print these things and they're functional, which doesn't require anybody to put them together, which is fun. So, I would say we've been talking for a while, and thank you for humoring us on all of this. Is that my sort of 3 points, if you were asleep and you're now waking up and thinking about going to grab a beer or whatever, because last call, is that the things that you have to think about is, when do you use additive technologies versus injection molding? Complexity is number one. More complex, more cost in injection molding. Additive technology, complexity is free. So volume, the idea that if you're printing something in low volume, go to additive manufacturing first. Upfront costs on traditional manufacturing can be really restrictive on innovation, and you want to take as long as you possibly can before you have to make that commitment and produce larger volume. And then finally, which sounds a little funny, is design confidence. If you're producing a part or you're producing an idea, like, hey, I invented this thing and I want to try this out, and you're working with your design engineer, and it's like, you're not going to stick the landing on the first try. It's like you're going to have to go through iterations. And so the idea is, like, if you don't have that design confidence of like, yeah, you know what, we're ready to produce 300,000 of these things, it's like, go to additive, because we can, it's one of those things where I tell people, it's like, hey, we get folks that are like, hey, I need 10,000 of these. And it's like, well, do you need 10,000 today, or do you need like 1,000 a month for 10 months? Because we can do the latter. We can't do the former, but we can do the latter. And usually what happens is when we move into relationships like that, about 6 months in, they're like, oh, hey, we need to change the design. Like, it's not working for us. And it's like, well, here's what you need to do. You need to send us a new file and we'll print it. And that's it.
So thanks, everyone. I guess the 4 takeaways we want to give you is, this is really an inspirational technology that's finally passing the hype into reality. Perhaps it's going to let you design in a new way where structure and skin are one, like nature intended. I think we want you to think about how you collaborate with your manufacturers to unlock this technology. And really think about ways it's not just the design, it is innovating that whole process.